Okay, this is the workflow for the G10 knife handles program. The first thing we're going to do is make sure that we're set up properly. And part of that is making sure that the waste board work area is clean so that the piece lays flat. Because we're using super glue and some other stuff, you get little blobs here and there. Left over from the previous operations. So you can kind of feel around, make sure that it's nice and smooth, get some of this crap off there. Just a tiny bit of sandpaper will work. This is 220. Get that extra blobs of super glue and tape off of there. Make sure it's nice and flat. So this is our workpiece. It's a piece of supposedly 1/4 inch G10. It's a fiberglass reinforced with resin. It's really super hard and abrasive, and it's tough on the tools, so don't be surprised if you have to change them quite a bit and take really conservative cuts. But like I said, this is supposedly a 1/4 inch, but the first step is to actually measure this and make sure that it is a 1/4 inch. And if it's not, we want to find the lowest spot and mark that corner. So to find the actual thickness, I use this digital micrometer. I'll be honest, I don't really trust it because they screwed it up at the factory and put the wrong barrel on here. It goes backwards. Get it pretty close to 0. I don't think it actually reads millionths of an inch, but what do I know? Get it pretty close to 0. Take it out to, I don't know, maybe 300. And I'm going to measure all 4 corners of the material. You can see this one's 258. Got another 258. Let's see. 263 and 262. So I know that these 2 corners are 258. I want to remember this, so I'm going to mark it on there with a Sharpie. Okay, I've marked these corners because it's going to be important in the next step. And the reason that we do this is we have to know the actual thickness so that when we touch off, we take off the correct amount. You got to know where you start and how much to take off in order to get where you want to be. Okay, so the first thing we're going to do is generate a facing toolpath to get our stock down to the appropriate thickness. I'll select top, zoom out just a little bit. I'm going to go up here to the top left and hit create sketch. I select the plane. I go up and I hit 2-point rectangle. Start at the origin, drag it out. Then I select sketch dimension. I pull this out and I hit 6 for 6 inches. Zoom out a little bit more. Then I pull this 1 foot. So this will encompass the entirety of the stock piece. And then I select finish sketch. I then select this sketch. I go up to the top left and hit extrude, and I tell it what size we want our finished piece to be, which is 210 thousandths, and press enter. So this becomes what our stock looks like and what we want it to look like. Now that that's done, we go to the design tab up here and we bring it down to manufacture. We select units, change active units, switch to inches, and press OK. Next we have to create a setup. This basically is the skeleton of whatever program we're going to be making. So we select setup. The first thing we do is zoom in on the bottom left corner, select the top point. This is where all of our programs are going to start from. It's the workpiece 0, if you will. We have to set up our stock, tell it what the stock looks like in the actual space. So for mode, I switch it to fixed size box. You can see that it's 6 by 12. Default height is a 1/2 inch, but we measured ours at 258 thousandths. The model position, so you can see here that this is our stock. It thinks we're going to be taking material off from both sides, as you can tell by this yellow. We want to switch model position under the height to offset from bottom. The offset is 24 thousandths. We want it to be 0. So now you can see we're only taking material off the top. We press OK. So now we've told it what we want our stock to look like versus what the stock actually looks like, and we can start to generate a toolpath. This is actually fairly simple. We go up here to the 2D area and select face. This is kind of a pre-generated facing toolpath. We want to select our tool. You have to input all these manually, but I always use a 1/4 inch 3-flute carbide in mill. Select that. Make sure that your coolant is disabled. We're going to leave spindle speed at 10,000 per right now because we are going to override that cutting feed rate. We do want to change. It's kind of our base feed rate. I start at 90, which gives us 3 thousandths of feed per tooth. We don't need to change geometry. We don't need to change heights. Passes, pass direction. Right now it's going to go horizontally, which is fine, but we get better tool marks. They're easier to take off if we change pass direction to 90 degrees. The step over is way too high. We're engaging too much of the tool at once, so let's do 75 thousandths. I like to turn chip thinning on. I like to check multiple depths. This means it takes, say, 3 passes instead of 1. Maximum step down should be 20 to 30 thousandths. We'll just go with 20 for right now. And let's see. We're going to select both sides. Linking is not important either. We're going to hit OK. And it's going to generate us a toolpath. We can zoom in, see that it's going to take 1, 2, 3 passes. We can right click on the toolpath and select Simulate. Over here in statistics, we can see it's going to take 34 minutes. We're going to override the feeds and the speeds, so we can probably get that down to about 20. We're going to go ahead and verify that this is going to do what we want it to. So I can see that it's taking 1 pass, should take 3 passes. 2 and 3. We exit the simulation. We right click on our toolpath and select post process. For post, you want to make sure that your selection is carbide 3D Gerbil. You may have to find out how to add that in. This is our output folder. This is where we want to save the file to. And for the name, we're going to call it 0.258 to 0.210 facing. And then we're going to click post. And down here in the right, we see NC code successfully posted. So we're ready to start facing. Okay, so now that we've got our facing path made, we need to fix our piece to the work area. Make sure it's plenty clean. And we're going to use the tried and true blue tape method. You don't want any bubbles, you don't want any dust, you want this to be as flat as possible. Try not to overlap your tape too much. Push that off to the side. Do the same for your base. Okay, so because we started our facing toolpath in the bottom left corner and we told it was 258 thousandths, we want our 258 thousandths bottom left corner. Make sure all the dust is off. To fasten it down, I like to use the Gorilla Glue gel. It gives a really good hold. I prefer to put it on the back of the workpiece as opposed to the table, so when it squishes out it goes onto the table and not onto the workpiece. You want a pretty good coating on here because we don't want this puppy to slip off. That's probably good. And then I'm going to flip it up, making sure again that 258 thousandths is in the bottom left corner. And I'm going to tuck it right up against our fence there. And I like to take a 2x4, place it across the top, and put some weight on it to hold it down flat while I wait for the glue to dry. I usually give it, I don't know, 10 minutes, 15 minutes. So we wait. Alright, so the tool that we chosen to do this, 1/4 inch 3 flute. So we're going to load it in. And tighten it down. This needs to be snug. It doesn't need to be gorilla tight. These collets do a pretty good job of holding the cutter in. We're going to press resume. It's going to come over and measure the tool offset so it knows exactly where the bottom of the tool is. Okay, next we need to jog the cutter directly over the bottom left corner because that's where we told it to start. It doesn't need to be precisely on the very center because this is just a facing path. But I like to bring it down. Spin it with my hand until I can hear it making contact. We can see now that it's taking a tiny little chip. I can see that it's taking a tiny little chip. So once I've found the corner of my piece with the cutter and I've found the height under the jog screen, I press set 0. X and Y have already been zeroed out, but I can see that my Z needs to be zeroed. So now we've told it exactly where the piece is. We told it where to start. 0, 0, 0, press done, and we can go back out to the run screen. we're going to load a new file. And we're going to find 258 to 210 facing and press open. We can see it's going to take 35 minutes. It uses one tool, which is already loaded. We can press start job. We press start. It'll measure the offset of the tool again. Then we install our dust boot. For the dust boot install, oops, you don't want the cutter hanging out the bottom. So I'll bring it down. Make sure it's not on when you're doing this. And I'll give it, I don't know, about an 1/8 inch to a 1/4 inch of bristles before it hits the cutter. We're going to turn on our spindle, then we're going to turn on our dust collector, and then we're going to press go. Okay, so after it's finished, you turn off the spindle in your dust collection, and we are going to load a new tool. So make sure you tell Carbide that you're going to load a new tool so it measures the offsets. The next two steps, use an 1/8 inch 2 flute with a 1/4 inch shank so we don't have to switch to collet out. And again, just snug, not stupid tight. When we confirm that we've loaded the next tool and press resume, it's going to measure the offset. Alright, at this point we're going to set the 0 for the rest of the project. We need to set the X, the Y, and the Z. We want them to remain consistent. It doesn't need to be dead smack in the middle, but you should eyeball it and try to get that corner directly in the center of the cutter in both the X and the Y. And we're going to do the same touch off for the Z that we did last time, where we just spin it until it starts to take just a little chip. So once we found our X, Y, and Z 0, make sure you press set 0 and clear them all out. Next, we're going to run a new file. And this one is going to be step 1, 0.125 bore. This does all the holes and the counter bores. Press start job. It's going to measure the offset. We're going to attach our dust boot, and then we're going to run it. Okay, so this is going to determine a lot of the rest of the project. When we look down in the boreholes, we don't see any blue tape. That means we need to adjust our Z0 down maybe about a 1/2 millimeter. So we're going to go back into jog. We're going to set our Z0 down 0.5 millimeters, and then we're going to rerun the program. Okay, now we've rerun the program. We see blue tape in every hole, and we haven't gone through to the wood very much, which means we are just about exactly where we need to be on the Z. So we're ready to move to the next step. Step two uses the exact same cutter. All the X, Y, and Z zeros are the same from this point out, except for one, but we'll get to that later. We're going to load a new file. Step 2 is the 1/8 inch contour 1. Okay, we're going to tell Carbide that we're loading a new tool. Whoop. We are going to load the chamfer path. Come on. And this is a 1/4 inch 3-flute chamfer. Very little deflection, super stout. Once you get the chamfer on, they actually start to look like knife handles. Okay, step 4 is a little tricky. It's the only 3D carve we have in the whole thing, and it's the thumb groove. It was really tricky to set up. So instead of going back and redoing the whole tool path when something screwed up, I learned that I had to offset the X 1 3/4 millimeters to the right. I rapid position to the current XY, takes us to our X0, Y0. I press done, and then I want to cheat it to the right, that way 1.75 millimeters. Watch my X over here. There's 1.5. I changed my increment down to 25 microns. 2, 3, 1.7, 1.75. I hit 0. I zero the X. 1.750. Remember that because we're going to have to change it back later. Then I hit run. We're going to load our next tool. Okay, the next tool is a 1/4 inch 3-flute ball nose end mill for putting in the thumb groove. Okay, so we've cheated the X. We've loaded our next tool, so we need to load our next file, which is the step 5.25 ball scallop. Start job. Start. Okay, now we've got our thumb scallops in there. Wonderful. They are almost done. We've got one last step. And that last step is to cut all these out. We're going to be using the same cutter from steps 1 and 2. It's the 1/8 inch with the 1/4 inch shank. Before we cut these out, it is critically important that we cheat the X in the opposite direction that we cheated it for the last step. So I go to jog, rapid position, current XY, press done. Increment is 0.25 millimeters. We want to move the opposite direction, so we're going to the left this time. X negative 1.5. Change it to 0.025 millimeters. We moved it 1.75 millimeters to the right. We're going to move it 1.75 millimeters to the left. 0. 0, just the X. The final step is the .125 final cutout. And if we've done everything correctly, it'll line up perfectly. Okay, once the cutout path finishes, you can see we just barely hit that blue tape, which means our depth is set just right. Our offset is just right. I got a little bit of cleanup here and there, but overall these are ready to be pulled up and moved to the sandblasting cabinet.